Hi, I'm Emily, and today we're going to teach you how to assign oxidation numbers.
First of all, what is an oxidation number?
The oxidation number of an element indicates the number of electrons lost or gained as a result of chemical bonding.
Also, it can show whether a species has undergone oxidation or reduction.
Here are some general rules for assigning oxidation numbers.
Rule 1. The oxidation state of an element is always 0. In this reaction that produces sodium chloride, sodium and chlorine are both elements and therefore are assigned an oxidation state of 0.
Rule 2. The oxidation state of an ion is the same as its charge. In this reaction, both nickel ions and zinc ions are present. Both ions have charges of +2. According to the rule above, nickel and zinc are consequently assigned oxidation numbers of +2.
Rule 3. In a compound, fluorine is always assigned an oxidation number of -1.
Rule 4. In a covalent compound, oxygen is assigned an oxidation state of -2, except when it is in peroxides and receives an oxidation state of -1. Also, in oxygen fluoride, oxygen is assigned a +2. In the combustion reaction of ethanol, the oxygen in CO2 is assigned an oxidation number of -2 because CO2 is a covalent compound. The oxygen in the hydrogen peroxide is assigned an oxidation number of -1 because H2O2 is a peroxide.
Rule 5. In a covalent compound, hydrogen is assigned an oxidation state of +1. Hydrogen receives an oxidation number of -1 only when in a metal hydride. In this reaction, the hydrogen in hydrochloric acid receives an oxidation state of +1 because HCl is a covalent compound. In the second reaction, the hydrogen in calcium hydride has an oxidation number of -1 because CaH2 is a metal hydride.
Rule 6. For a neutral compound, the oxidation states must add to be 0. In the following reaction, where sodium hydroxide is produced, NaOH is a neutral compound, in which the oxidation numbers add to equal 0. Sodium receives an oxidation number of +1 because it is in group 1 of the periodic table. Hydroxide receives an oxidation number of -1 because this polyatomic ion always has a charge of -1. Sodium's +1 and OH's -1 add to equal 0.
Rule 7. For a polyatomic ion, the oxidation states must add to equal the charge of the ion. In the polyatomic ion, OH negative or hydroxide, the oxidation states add to equal the overall charge of the ion, which in this case is -1. Oxygen receives an oxidation number of -2 because it is within a covalent compound, which is stated in Rule 4. Hydrogen receives an oxidation number of +1 because it is in a covalent compound as seen in Rule 5. Oxygen's -2 and hydrogen's +1 add to equal -1, which is the charge of this ion. Now we know all these rules, but how do we apply them? Let's start by showing you an example. Let's find the oxidation number on manganese in the following compound. Potassium. It is given an oxidation number of +1 because it has a charge of +1. The oxidation number of manganese is still unknown at this point, so we'll assign it the variable x. Oxygen is usually assigned an oxidation number of -2, unless it falls under an exception. In this case, an exception does not apply. Oxygen has a subscript of 4, which must be multiplied by oxygen's oxidation number. As we know, this is a neutral compound, so the sum of its oxidation numbers must add to equal 0.
Now we have set up an equation that can help us. Find Mn's oxidation number. First, multiply -2 times 4, which equals -8. Simplify the equation, and now we have 1 plus x minus 8 equals 0. Combine the like terms, -8 and 1, which equals -7. Now the equation is x minus 7 equals 0. To isolate the variable, add 7 to both sides. X equals plus 7. Therefore, the oxidation number of manganese in KMnO4 is plus 7. Now it's your turn to assign oxidation numbers. You may pause the video to work out these problems if you like. Number 1. What is the oxidation number of sulfur in SF6? Number 2. Assign oxidation numbers to all of the atoms in NO3 negative. Number 3. What is the oxidation number of selenium in HSeO4 negative? Number 4. Assign oxidation numbers to all the atoms in the following reaction. 2Fe plus 3Cl2 yields 2FeCl3. An answer key is provided at the end of the video.
Thanks for watching!